follow along to do some practice problems on limits involving infinity. Okay, so I would recommend you pause the video to try the problem first once it appears on screen, and then unpause it to see how I work through it and check your answer. Okay, number one, this is just a general conceptual question. Explain how horizontal and vertical asymptotes are related to infinity. Okay, so this probably won't be asked in the AP exam, but we need to know this concept. So a vertical asymptote is when as x approaches a number, the value of the function approaches either positive or negative infinity. So some examples, limit as x approaches a, f of x is infinity, or even like limit as x approaches b from the right, f of x is negative infinity, something like that. Okay. As we approach some number, the value approaches infinity, either positive or negative. That's how asymptotes work. It keeps growing infinitely or keeps decreasing infinitely. Okay. Horizontal asymptote is as x approaches plus or minus infinity, the value of the function approaches a number. Okay, so limit as x approaches infinity of x is equal to L, something like that. Or we go the other direction, limit as x approaches negative infinity of x is equal to sometimes the asymptote is the same number, sometimes they're different. Okay. Number two, if m is an even function with vertical asymptote as at x is equal to 2, and limit as x approaches infinity, m of x is equal to 0, draw a possible graph of m of x. Okay. Here's one possibility. All right. Basically, vertical asymptote as x is equal to 2, I would draw the dashed vertical line like right there. Okay. Limit as x approaches infinity, m of x is 0. That's a horizontal asymptote of y equals 0. So I would start drawing that. And then to connect the dots or connect the pieces, since we know this is the asymptote over there, we can draw it approaching this vertical asymptote this way. Okay. And it says even function, by the way. So that means we have to reflect it about here as well. So let's worry about just the positive x, and then we'll reflect it on the other side, okay? And then vertical asymptote at x is equal to 2. So we can draw something like approaches like that, okay? And then this is even function as it says, so we just flip this like a mirror on the other side. Okay? I don't think that was too important, but here's number 3 now. We want to evaluate these two limits. This is more important, in my opinion, at least. So go ahead and try these first on your own. Okay, number 3, part A, I did 2 methods. I could have done 3 methods, but I only showed 2 here, okay? We can actually do it the quick way that you probably learned in Algebra 2 or pre-calculus or whenever you learned it, okay? This is a rational function. How do we determine if there's an asymptote for rational functions, a horizontal asymptote? We do the degree test. If you remember, there's like 3 cases. If the degree at the top is bigger than the degree at the bottom, there's no horizontal asymptote. The degrees are the same. Then you take the ratio of the leading coefficients. And if the degree at the top is less than the degree at the bottom, there's an asymptote of y equals 0. Remember that stuff? You can use that here, actually, because this is asking, what's the horizontal asymptote? Okay, so if we remember those 3 cases, and you might have a solid understanding of that if you actually know how to calculate this limit, which I do in method 2. Okay, if we remember those cases, we do the degree test. The degree of the bottom is bigger. So what's that horizontal asymptote? It's y equals 0. The limit is therefore 0. The y value approaches 0. That's the definition of the horizontal asymptote. Okay. This is how we properly calculate it, though. We factor the biggest degree on the top, which is x to the 4th. Do the same thing on the bottom, which is x to the 5th, though, okay? So remember, when it's 1 over x to some power, the limit as x approaches either positive or negative infinity is 0. So we want to make it look like this. Powers of x on the bottom. Positive powers of x on the bottom, okay? So that's what I factored. Now, this can simplify to just x on the bottom. So now I start taking the limit. This term would approach 0. This term would approach 0, as I was explaining earlier. So we left a 6 on top. On the bottom, this term would approach 0. This term would approach 0, but we still have this x here, okay? properties of limits, I can take those limits first and then do this. Yep. So what's the limit as x approaches infinity of this guy? It's 0. Okay. 3b. This is the more complicated one. But you can think of it like we did over here, the degree test. It's a little different because it can be either plus positive or negative. So I'll explain that in a bit. Okay. But we can kind of do the similar thing here to get the ballpark number. Okay. Degree at the top, biggest degree is x to the third. Okay. What's the biggest degree on the bottom? You can think of it as we take the biggest degree inside the radical, which is x to the 6. What happens if we square root x to the 6 is x cubed? Okay. Technically it's plus or minus, but let's take the plus first, okay? I'm trying to explain x cubed. So the biggest degree on the bottom is like it's x cubed. Okay. So what's the leading coefficient then of the top and the bottom? Because now the degrees are the degrees are the same, right? 5x cubed is on top. Square root of 7x cubed is on the bottom. So the asymptote is plus or minus 5 over square root 7. Okay, so before I even go through the math, that's what I got over here. Okay, so that's the quick way to kind of eyeball it, per se. The only problem is it could be either positive or negative. So that's where you have to do the math to check that whether it's positive or negative. Just because it's approaching infinity doesn't mean it's just simply positive 5 over root 7. That's the mistake most people make because they're lazy and they don't understand actually what's going on in the math. Okay, so this is what's happening. Okay, so we do similar to before. I factor out the biggest degree on the top and biggest degree on the bottom, but inside the radical. Okay, so that's this first step. Okay, so properties of radicals, I can rewrite it like this, split it up. Okay, square root of x to the 6. This is precisely where the plus or minus comes from. Okay, you can rewrite this as absolute value of x cubed. Now, as x approaches infinity, x cubed, which branch are we on as x approaches infinity? We're on, if you remember, if you look at my cursor, x cubed looks something like this, right? So we're on the positive, this branch over here, okay? Versus if we were approaching negative infinity, we'll be on this branch over here. So we actually want to replace x cubed with minus x cubed, okay? But since we're on the, because we're approaching infinity, we're on this branch, the upward branch over there, okay? Hopefully you can imagine what my cursor is doing. So we replace this absolute value of x cubed with x cubed. Now, if there were a minus inside, this is where, what was this? This is where most people would get it wrong because they just blindly think that, or they just think, blindly think is not even a word, or saying, they just think that as x approaches infinity, it's always plus, but no, that's not the case. If this was a minus inside, then it's a different story, okay? But anyway, so we replace the x absolute value x with just positive x cubed, so those would cancel. And then now we take the limit, if you follow the steps, that's 5 over root 7. Okay, so the quick way to eyeball it, once again, is pretty much the same as in part A. Okay, number 4, last, actually no, there's a few more. Given f of x is this guy, a and b are positive integers, f has horizontal asymptote at y equals 2, f has vertical asymptote at x is equal to 3. Find the correct values of a and b. Find the point of removable discontinuity on f. So go ahead and try this first on your own. Okay. So we're going to use all the pieces of information they give us to find a and b. There's a HA, a horizontal asymptote at y equals 2. Okay, let's use that piece of information first. How do we get the horizontal asymptote of a rational function? What did I just say for that we did before, even before calculus? The degree test. Degrees are the same. Take the ratio of the leading coefficient. So the asymptote would be b over 2. Okay? So you just set 2 equal b over 2, which means b equals 4. We found b. Okay, now let's use this other piece of information. Vertical asymptote at x is equal to 3. That means there's probably going to be an x minus 3 on the bottom. Okay, this x squared minus a squared factors as x plus a, x minus a. Okay, so that means a is 3. So from here, a could be plus or minus 3. Okay, but they tell us a and b are positive. So we say that a is 3. Okay. Now let's answer part B. To find the removable discontinuity. Okay, so I plugged in my A and B already, right here. This is our f of x, okay? So if we make a very educated guess, we can probably safely guess that the removable discontinuity is that x is equal to 3, minus 3, sorry. Okay, because remember, the vertical asymptote is that x is equal to 3. So the x minus 3 would contribute to the vertical asymptote, okay? The whole or the removal of this continuity must be the other thing that we can't divide by, which is this x plus a, which means that the whole occurs at x is negative 3 probably. Okay, now we can show our work for that though. That's our initial guess, a very educated guess. Okay, let's start factoring. The bottom, as I just said, should factor to x plus 3, x minus 3. That's how we even found part A. Okay, the top, we could first factor a 2 to help us out, and then this, hopefully it's simple to factor, is 2x plus 1 and x plus 3. So you can see the x plus 3s would cancel, and that's our removable discontinuity. That's our whole. Okay, hopefully that makes sense. Number 5, I don't think this is too important, but here's a practice problem. Draw a function g that satisfies all of these properties. Okay, let's go ahead and try that. So here's the example function right over here as reference. I'm not going to go over this one. I don't think this is too important. Okay, so the key things I want to hope that you take away are, for sure, this type of problem. This is probably finding this B and A. This is probably a standard multiple choice question even, maybe free response, but I feel like it'll be more common multiple choice question. And these limits are important to know as well. These ones with the square roots and taking it to infinity. Okay, hopefully you took away something from one or both of those things, okay? Please give this video a like if it has helped you in any way, and hopefully see you in another video as well. Bye.